All right, explain why f of x, which is defined as x cubed plus x squared, has no inverse. And we're going to show why it has no inverse graphically. So let's start by graphing the function. F of x equals x cubed plus 2. Well, that's going to be x squared times x plus 1. And so we go ahead and figure out our roots. So f of x equals x squared times x plus 1. So we get a double root at 0, single root at -1, and it's got a positive leading coefficient, and it's an odd function. So it's going to start down from negative, y equals negative infinity, or y is heading towards negative infinity, head up, and end at y heading towards positive infinity. So here we are. Sketch that graph. Looks something like, again, just a sketch, a little double root here, heads back up. And it's probably should be a little more curved than that, but you get the rough idea here. So remember we talked about that a test to see whether or not something has an inverse is the horizontal line test. That if it has a line, if you can have a line going horizontally and it goes through more than one point, then it's not a function, because once I were to flip it or reflect it over y equals x, because if we were substituting the x and y values, that's kind of how we would find the inverse. It would look something like, well, let's kind of sketch in the line y equals x. It would look something, and just very roughly, let's see, it'd be a double root at 0, so -1. Looks something like that. And we can see here that this wouldn't pass the vertical line test. This green one is not a function. So since it's not a function, it has no inverse. But let's, rather than doing all that work, all we need to see is that it doesn't pass the horizontal line test. So in the original blue one, right here, it has multiple values, multiple points that it's going through. And so from the very beginning, you can see that using a horizontal line test, this will not have an inverse. That once we are plugging the y value right now of, let's say that's a half, back into the function, we'll get out 3 into the inverse rather, what would be the inverse. We'd get out 3 different x values. And so we aren't able to say what is the inverse, because, well, when I plug in that value into the inverse, I'm getting 3 different outputs, and so it's not a function, and it is not an inverse. So, all right, hope that helps.